I'm Quentin Allen, and I'm the previous operations manager here at Kansas State from October 2010 to July 2012. Today I'll be taking you through the mill startup and some of its operations principles, so sit back and enjoy. Beginning each run, I always take the opportunity to write down in the operations notebook the starting weights for all the temper bins. These are the wet weights coming out of the flow balancer on the pre-temper bins, so they're going to be slightly off as some of the water has evaporated throughout the evening. So as I complete writing these down, I will notice that the PMC module needs to be started to ensure correct communication between the PLC and the equipment. So you can see that there's no job available. There's no paper listing on the right hand corner, so I go ahead and click Start PMC in the upper left hand corner. It always needs to be started if that's the case. Let's give it about 10 more seconds here and it will finish initializing and we can begin the job. Okay, so you can see on the right hand side of the screen we now have our several papers listed there that we can click to open up the jobs. I'm going to go ahead and fast forward to the creation. We're going to begin here by pulling up the jobs overview screen and selecting new. We get to the jobs overview screen by selecting the multiple paper icon on the right hand side of the screen. Now I've got the screen frozen here for a few minutes where we can talk about each of the fields and some typical input values for each of them. The first box on the top of the screen that is blank, you'll see patent product ID. What we typically have here is hard red winter patent, but it can change based on the variety of wheat we're milling. The clear product ID, even though we may not be making clear product, always needs a selection in the field. In this case, it would be hard red winter clear flour. As we move down and to the left, we'll see the next box is first break target weight. What we usually do here is overshoot the value by 500 to 1,000 pounds that we have calculated temper wheat. We don't want to undershoot this value as the mill will start to shut down once it reaches that target weight. And typically we want the mill to run itself out. Moving down the left hand side of the screen, the next field is the bin flow rate. This typically is set at 2,400 pounds per hour if we're running the mill at 1 metric ton or 2,205 pounds per hour. We always want to keep this about 200 pounds per hour more than the first break flow rate so as to keep the surge bin full above first break, i.e. we don't want to run the mill out of wheat. The next field we'll see is the second clean water flow, which is always set at 0 unless we are doing a second temper. In the same general area, we'll see several checkboxes of equipment that we can select to use during second cleaning. The first checkbox is the sterilator, which I typically use. The next checkbox is the Sortex machine, again, which I typically use. If you move up and to the right in the same general vicinity, you'll see divert to scourer. I check that box. I like to use a scourer. The next box is to use the peeler, and the next box is to bypass the scourer. This typically remains as a choice even though we've selected divert to scour, so just ignore that open box. And of course the peeler is only used in special applications. Directly below these choices are a box that's labeled Durham job parameters, which you can bypass the 1-2 mids roller mill and or a combination of the detachers. And what I always do is bypass detacher 3000. That's the detacher after second mids. Without bypassing this detacher, the load on the back half of the mill is not correct. You won't be able to load up third mids, fourth mids, and fifth mids adequately if you use this detacher. And of course the 1-2 mids roller mill checkbox remains unchecked, as we typically like to use the double high. We're going to move down to the left again, straight below those parameters. We have our senders. Typically what I do when I fill up the tempering system, I use either the evens or the odds, most often the evens, just because T6 is an overflow bin and you don't have to walk to the other side to open up the bottoms when you are ready to run. So what you want to do is make sure and check the box that says blend bins and adjust your percentages accordingly to where they all equal 100%. Moving up and to the right, to the middle of the window, you'll see the whole wheat flow rate that is defaulted at 100. You leave that alone. That is for the whole wheat grinders, and you only adjust that when you're running that system. First break flow rate, that is set at 2,205 pounds per hour, and or whatever flow rate you want to run the mill at. Typically we run 1 metric ton per hour. In that box as well, you'll see 4 check boxes if you'd like to bypass any of the purifiers. Those valves are manual, that you'll have to walk upstairs to the 3rd floor to change if you would like to do that. You can also bypass the Brandon Shorts dusters from that box. Moving down to the next box, you can see that the flour job parameters, send clear flour to patent. If you'd like to make straight grade flour, you need to check that box. That also is a manual valve. It's on the 5th floor that you'd have to change if you'd like to make clear and patent flour. On that note, we'll move down to the receiver bins. For patent flour, from the drop down menu you can select F1 and F2. For large runs, I would recommend selecting both of the bins. You'll have a hard time going back and changing them later, and it will likely knock down the mill if you don't have those in there from the get-go. When you flip to the clear flour tab, you have to select F3. The job will give you an error if you don't. Even if you're making straight grade flour, which you can only fill bins F1 and F2 with straight grade flour, you have to select F3 as a clear flour bin. The mill feed is defaulted as L3. From that point, I would recommend putting some remarks into the comments box. Go ahead and save the job, check the job. If there are no errors, you can hit manually start and the mill will start to sequence up. I went ahead and unfreeze the pane here so that we can see me going through and making this flour job. And this is not sped up, so you'll be able to see the order in which I go through these things. It's just the logical order in my mind. We talk through them just down the screen. And I just go through and I select things as I am able to remember them so that I don't mess things up. So I'll let you go ahead and watch the rest of this, and we'll come back once we start up the mill. Immediately here we see the error there, the second clean and mill. So I'm flipping over to the second cleaning screen to check out why. You see that the Sortex is faulted, and what that means is that no one has went and initialized the controls yet, so those automatically don't come on. You have to go upstairs and turn on the Sortex machine before the mill will run. And that's taken care of on a checklist now that's available in the students folder online. Now we've skipped through some of the logic here. The aspiration's already started up. The screenings collection has started up. I'm increasing the air makeup system air anywhere from 60 to 85%, depending on how you have the outside dampers set. Now we'll watch the system in reverse start up. This is typical of the logic where your wheat is going, starts up first, and it starts up in reverse to where it's coming from. So you can see that the scour aspirator are on, the innoliter infestation destroyer is on, and now we're feeding wheat into the system from the bottom of the temper bins, the flow balancers, and you can see that the green line shows where the product is going. Finally ends up with the Sortex. Sortex blows it back up into the first break bin. Now the mill won't start up until the low level on the first break bin is covered, so it'll turn white. Low levels are either blue when they're uncovered or white when they're covered. High levels are white when they're uncovered and red when they are covered. Same logic applies to blow lines. When a blow line is uncovered, which means no product is going through, it's blue. Whenever there's product going through it, it's in its operating range, the blow line will show white. You can see that there on the one cleaning system line right now. And if there's a high level, there's too much pressure in the line, the blow line will show red. And if you watch this, and if you listen to the wheat, you should be able to hear the first set of wheat come down, go up through the cyclone, come down, back through the process. You should hear the second pickup line go, and on to the third. Easy way to check this, once this is all happening, is if all three of the wheat lines to the mill are in fact transferring wheat. So if you happen to not hear wheat for a while, then you know that something's wrong. There's perhaps a blow line that's apart, or some other malfunctioning piece of equipment that the automation is not telling us. Fast forward a little bit and you'll be able to see that the low level on the first break bin is covered now. The mill is in a wait status and says that it's ready for available test. So now begins the mill startup sequence. Once the mill has completely started up, all the equipment is running, the continue line button will illuminate and it must be pressed for wheat to go to the mill. I've got a screenshot here of the mill as it is running. You can see all my parameters and how they've been set, and all of the equipment is running in this case. And here we are moving to a mill fault. On startup, it's a good possibility that a roll stand will fault out for one of the bridging alarms being triggered. So what you do is you press the triangular button actually on the roll stand, then acknowledge the fault inside on the PLC, and at that point you can start up the line. You can see that the sifter is shaking out, and it won't let you restart the mill until all that has been cleared and the sifter is shaken out. What I'm doing here is just checking the fault, see what fault it was, and basically now we're just waiting for the mill to restart. We're going to cover now what happens when a cinder bin goes empty. You can see second cleaning is faulted out. What we're going to do is flip over to the second cleaning screen and open up the job. And what we're going to do is actually select one of the cinders, the one that's empty. So we'll open up the job, select the one that's empty, take it out of the job, reset our percentages to equal 100%, save, check modify, close, close, and reset the fault. Reset fault. And when it gives us the continue line, we go ahead and continue the line. Second cleaning will continue. Once the last cinder bin goes empty, we want to hit sequence stop and continue the line. So we reset the fault, sequence stop, and continue line. And you can see the second cleaning is now in the emptying stage. Once all the product is through the blow lines, all the timers have run out, second cleaning will say idling. So right now, basically what we're doing is we're waiting for the first brake bin to go empty. That's all there is left in the system. It's approximately 15 minutes of wheat, give or take a few minutes there. So we're going to go ahead and fast forward to the first brake bin going empty. Now after first cleaning is idling, you can see that the mill says it's in emptying state. What we're now waiting on is the flow balancer, the scale below the first brake bin, to actually go empty. You can see that the low level is now showing, so it should be a matter of seconds here before the actual scale flow balancer goes empty, and there it is. So it's flashing in red. What we do is we reset that fault, acknowledge that fault. There, it's acknowledged. And from that point forward, we're basically waiting for the empty mill timer to tick down. Now I'm going to explain to you the most efficient way to shut down the mill. If you don't follow these instructions, the mill is going to fault out when it's trying to empty, and you're just going to have to reset fault after fault for the mill to finally empty itself. You never want to hit immediate stop, as some people might lead you to believe. What that does is it basically stops the mill in its tracks. It's basically like hitting an emergency stop. Lifts will drop out, product will be left in lines, and it's just not a good thing overall. And with the counter finally counting down, I'm going to explain to you what's going to happen next. Basically what we're going to do is you have to be logged in as the administrator to do this. Password's admin. And what we're going to do is it ticks down, we're going to hit reset line and hit OK. And it stops the mill. And basically what we've done is we've given the mill at least ample time to shake itself out, to where we're not going to be dropping product out of lifts, and there's not going to be a lot of residual product left in the blow lines or the suction lines. Now we'll see that the sifter will count itself down again from a pre-specified time, and then the machinery will start to cycle itself off in the correct logical manner.